Alright, let's take a look at example 4. Engineers use vertical curves to improve the comfort and safety of roadways. Vertical curves are parabolic in shape and are used for transitions from one straight grade to another. Each grade line is tangent to the curve. So here we have the two slopes, and here's the vertical curve. Right? The word tangent means that the vertical curve just touches the grade line. There are several vertical curves on the Trans-Canada Highway through the Rocky Mountains. To construct a vertical curve, surveyors lay out a grid system and mark the location for the beginning of the curve and the end of the curve. Another section of road requires the curve shown in this diagram. Right? We've got a hill here, two grade lines, and here's the vertical curve going between them. The grade lines are modeled by the equation y equals 0.08x plus 6.2 and y equals negative 0.75x plus 6.103125. Right, the first one has positive slope, so this is the one with y equals 0.08x plus 6.2. This grade line has negative slope, so that must be y equals negative 0.75x plus 6.103125. The curve, this part in between, is modeled by the equation y equals negative 0.02x squared plus 5.4. Let's take a look now and see what the questions ask. So A, write the two systems of equations to use to determine the coordinates of the beginning and the end of the vertical curve on a surveyor's grid. Second, using graphing technology, show the surveyor's layout of the vertical curve. And C, determine the coordinates of each end of the vertical curve to the nearest hundredth. Alright, let's take a look at A. For the beginning of the curve, alright, to figure out the beginning of the curve, we have to make a system of equations out of the positive slope line and the parabola. So we have y equals 0.08x plus 6.2. That's our positive slope line. And our curve is 0.002x squared plus 5.4. Our ending curve is made up of the negative slope line and the parabola. So the equation of the negative slope line is negative 0.075x plus 6.103125. And again, the equation of the parabola is 0.02x squared plus 5.4. These are the two curves that we have systems of. To figure out where our curve is going to start, we use this first set of equations. To figure out where our curve is going to end, we use the second set of system of equations. Alright, B says, using graphing technology, show the surveyor's layout of the vertical curve. To do this, we're going to use GeoGebra to lay it out and take a look, see what it looks like. Right, we already have a graph up there, so we don't need to sketch our graph. Alright, let's launch GeoGebra. We're going to make our window full screen and center our axes and turn on the grid. It'd be nice if there was a way to make that the default. I'm going to now type in the equation of the line with positive slope. And it should be coming up here in just 1 second. There it is. And next I'm going to input the equation for the parabolic vertical curve. That's going to be the hill in our road. And there it is. You see it curving sort of a way down to the right. And finally, I'm going to put in the equation of the line with negative slope. And it should be coming up here. Alright, now I can't quite see the points of intersection of those lines, so I'm going to grab the zoom tool to zoom out a little bit, or maybe one more step. And there, now I can see the points where the curves and the parabola and the lines intersect. And we're going to use the intersect command from GeoGebra to find the exact coordinates. You can see the intersect command gives us the point -20 and 4.6, and 18.75 and 4.7. Right. Determine the coordinates of each of these vertical curves to the nearest 100th. Again, we're going to use GeoGebra to do this, and we find out that the point of intersection for the beginning of the curve, let's see, the beginning of the curve, and it happens at -20 and 4.6. And the end of the curve occurs at 18.75 and 4.7.